Okay, the purpose of this video demonstration is to go over how to factor binomials, and particularly what kind of binomials am I looking at, where a binomial is a difference of cubes and where the binomial is a sum of cubes. Now let's talk about what that means. What is in a name, right? A difference of cubes. So let's do number one first. Well, a difference means a subtraction, doesn't it? A cube is something to the third power, so like 2 cubed or x cubed. Let's do something like x cubed, and let's subtract 8. Now, this is a really easy demonstration. You can make this obviously a lot more complicated, but let's just see what this one looks like. I can rewrite 8 as 2 times 2 times 2. I can write x cubed as x times x times x. Now I'm just doing these little things off to the side just to help me out a little bit. On these really simple problems you don't have to worry about it so much, but on more complicated ones they actually sometimes help. Okay, if I've determined that my binomial is a difference of 2 cubes, then it follows a really strict pattern in order for it to be factored. And let me show you what that pattern is. You put down enough space for a binomial and a trinomial, because remember what factoring means. You're trying to find the number of factors. When you multiply them, you'll get back to the original answer, in this case x cubed minus 8. Now, a difference of cubes follows, once you've got the space for a binomial and a trinomial, the difference of cube has a minus, a plus, and a plus. Now that's something you just have to memorize, and there's ways of actually doing that. I usually say whatever you start with is what you start with here. So if you have a minus in your problem, you start with a minus in your binomial. Then you go plus plus, and you just memorize that. Now you've got 1, 2, 3, 4, 5 different spots to fill in. What do you put in each one? Well, let's see here. How about, let me just do this. In the first slot, you are going to put in here one of those factors. You're going to put that right there. In this spot, you put in x times x. So you put in x squared. In this spot, you put in one of the 2's. Let me just make these arrows go. It's going to be kind of complicated looking, isn't it? And in this spot over here, you're going to put down 2 times 2, or 4. Now you've pretty much taken care of everything you need now, except for this spot right here. What goes in here? You put this one times this one. Always put in the singles. Whatever this factor is, whatever that factor is, and you put down 2x. Now, if you were to remultiply or redistribute this times this, you'll get x cubed minus 8. That's why we call this factoring. Let me show you how to do that. If I've got x minus 2, let's put this in the box method. You'll notice I had the box method in a previous video. X squared plus 2x plus 4. Let's make that plus the opposite. Wherever I have a plus, I'm going to draw a line. And now I'm just going to go ahead and have 1, 2, 3, 4, 5, 6 simple problems. X squared times x is x cubed. X squared times negative 2 is negative 2x squared. X times 2x is positive 2x squared. 2x times negative 2 is negative 4x. 4 times x is positive 4x. And 4 times negative 2 is negative 8. Now look what happens. X cubed. These guys cancel. These guys cancel. Minus 8. So what is this telling me? It's telling me that this times this gives me x cubed minus 8. Okay, so again, let's go through the pattern one more time. When you see that this is a cube and this is a cube, and you've got a difference between them, put down the following signs: minus, plus, plus. Again, remember, how do I know that? If you start with a minus, you start with a minus here. This one's always the opposite, and the last one's always going to be a plus. Then you take one of the factors and you put it here, and you take the other two and you put it here. You take one of the factors and you put it here, the other two factors, you put it there, and then one of those times one of those, you put it there. Okay, let me try another one for you to show you how complicated these can get. We'll call this example 2. Let's say 1 over 27y to the 6th minus, let's see here, how about 64? Now, again, this is a binomial, and you ask yourself, is this a difference of cubes? Now, you're going to have to kind of know your numbers pretty well for this one, but this is a difference of cubes. Let me show you why. 4 times 4 times 4 is 64. So I could rewrite 64 as 4 cubed. It's a cube. 27, y to the 6th, is just 3y squared times 3y squared times 3y squared. Now, how is that possible? Well, remember, 3 times 3 times 3 is 27. Break it down. And y to the 6th is just y squared times y squared times y squared. If you remember your laws of exponents, your rules of exponents, when you multiply and the bases are the same, you add the exponents. So it gives me y to the 6th. And 1 is a great cube because it's just 1 times 1 times 1. So everything's a cube in this. This is a difference of 2 cubes. So what do you do again? You put space for a binomial and a trinomial. You go minus, plus, plus. You take one of these factors. So I say 1 goes here. The other 2 go there, 1 times 1. You take one of these factors. 3y squared goes there. The other 2 go here, 9y to the 4th. You take one of the factors, you put it here, you take the other 2, put it here, and then you take one of each. This 1 over 3y squared times 4 gives you 4 over 3y squared, and there's your answer. If you were to FOIL this or to multiply this, you'll find that things cancel out and you'll get back to your original equation. I hope that helped. I'm going to actually do another one for you. I'm going to do a sum of cubes to show you what the difference is. Now, the sum of cubes, again, what's in a name? Well, the whole thing, the sum of cubes. Let's go back up here and rewrite this problem. We already know that that's a cube, don't we? We already know that that's a cube. We used it in our first example. I'm going to do the exact same thing and show you how similar these two are. Now, a sum of 2 cubes follows pretty much the same kind of pattern except for the signs that you put down. Put down a binomial, trinomial, space, and this time, since it has a plus, you start with a plus. The middle one is always the opposite. The last one is always a plus. Again, look how that differs from a difference of cubes. A minus, for a difference of cubes, you start with a minus, you start with a minus. The second one's always opposite of the first, and the third one's always a plus sign. So let's go back down here. Otherwise, you put everything in there exactly the same way. One of them goes here, 2 of them go there. One of them goes here, two of them go there, one of each goes there. Again, if you were to multiply these two, you'll get back to the same answer. I'll leave that to you to do. Okay, I hope that helped. If you just memorize the sign patterns, I think you'll be okay. Remember, put down binomial, trinomial, space, plus, minus, plus, if you start with an addition, and then you put one of them in the beginning. Excuse me, one goes here, two goes here, one goes here, two go there, again at the end of the polynomials, and then one of each goes here. All right, good luck with that.